This is the homework from 11:30, the markup and markdown review. Section 1 is just matching vocabulary. So original price plus the markup or minus the markdown, that's the sales price. That's the original plus whatever the change is what you end up paying. Percent increase in price is, it says percent, so I know I'm looking for either markup rate or markdown rate. That's in percent increase, so that's markup rate. Price before markup or markdown is the original price. Dollar amount of increase in price is the actual markup. Percent decrease is markdown rate. And then dollar amount of decrease in price is markdown. Section 2 is fill in some blanks. To find the sales price after a blank, we use this formula. It's 1 plus M. That's the markup formula. Because we're adding M in this equation is the markup rate. And if we add that to 1, that's like saying that the new cost is more than 100% of the old cost. M is the markup rate. To find a sales price, so this one must be marked down. And M is the markdown rate. Remember that the rate is the percent. To apply two discounts, the first discount price becomes the blank when calculating the second discount price, the original price. Two discounts is like two problems but in one, really. All right, section 3. This is where we match this expression to the correct thing on the left. X plus 0.25x. In this section, x equals the original price, and the math expressions that have the letters A, B, C, D, those are all doing something to the original price, and you have to figure out what it does to the original price. X plus 0.25x, that's like the original price plus 25% of the original price. That's a 25% markup. So on the next page, that's number 25 is A. B is x minus 0.8. That's like an 80% discount. X minus 80% of x. You're taking off 80%. So that's the first one, number 12. C is 0.6 times x. So the new price would be 0.6 times x, or 60% of x. That's not really one of the options. But if the new price is 60% of x, that's like a 40% discount. If you're only paying 60% of what it used to be, then it's 40% less than what it used to be. So C is a 40% discount, number 24. D, 1.15, that's like saying 1 plus 0.15. That's a 15% markup. D, 0.9 times x, that's 90% of the old price, which is 10% less than the old price. So that's a 10% discount. E, 0.7 times x, that's 70% of the old price, or 30% less than the old price. So 30% discount or 30% markdown. That's number 15 right there. G, 1.05, so that's 0.05 greater than it used to be, or 5% greater than it used to be, or a 5% markup, number 16. 1.3, that's 30% larger than it used to be. So I don't see any 30% markups. Oh, there's a tip. Okay, yeah. If you pay a tip, then your total that you pay will be 30. A tip is like a markup. You're paying more than what it cost. So H could go on number 18. X plus 0.07, so that's 0.07 times the original larger, or 7% larger. I don't see a 7% markup. I don't see 7% tip. Oh, there. If there's tax, that's also the same functionally as a markup. So I can go there. Number 19. J is 0.05 larger. That looks like a 5% tax, or 5% markup. K is 0.93, so that's 7% less than it used to be. a 7% discount, number 20. That's all of the letters on the first page. All right, let's see. X minus 0.15. That's a 15% discount. So L is number 17. 0.9, that's 0.1 less or 10% less or 10% discount. That's number 23. N is 1.2. That's 20% more. 20% tip. Okay, yeah, that's number 13. O is 0.1x or 90% less than it used to be. O is number 30. 1.35. That's 35% more than it used to be. Q is 0.83 or 17% less than it used to be. When I say that so fast, it's because I'm thinking about 1 minus 0.83, which gives me 0.17, which is 17%. So I'm just finding the difference between 100% or 1 and that number. X plus 0.08, so that's 0.08 times larger, or 8% larger, which an 8% sales tax would do. 0.12, oh, there's only one left, and it is the right one. All right, part 4 are some word problems. It says show all work, substitute the values, and solve. Marshall's been saving up to buy a new baseball mitt. The sporting goods store has a sale of 30% off any one item. If the baseball mitt costs $110, how much should Marshall expect to pay before tax? Okay, so it's 30% off of $110. So the new price, or the sales price, will be 1 minus 0.3 times the original $110. The formula I just used is Q equals 1 minus M times W, where Q is the sales price, W is the original price, M is the markdown rate. And that would give me 0.7 times 110, which is 77. All right, B, before reaching checkout, a stranger gives them, take an additional 15% off any purchase coupon. How much does Marshall pay at the checkout before tax? So now the original price is 77 because I'm doing another discount after I already did the first discount. So now 1 minus M times W. Now it's 1 minus 0.15 times 77 because I already took one discount. This will be $65.45. C, what percent of the original did Marshall end up paying? So this is not a markup or markdown problem. This is what percent of the original price. So this is like the very first percent problems we worked. That's like saying Q equals P times W. The part is 65.45. The percent is what we're looking for, and the original was 110. So divide by 110, divide by 110. The new price is 59 or 0.595 or 59.5% of the original price. All right, number 32. I think I'm going to need more room to do this one. All right, 32 says, in order to make a profit, Jan's clothing outlet must mark up the items that they sell. Since many items come from different manufacturers, the markup rate varies. Jan's clothing outlet sells jewelry with a markup rate of 75%. If the original cost of a necklace is $28, how much is the sales price? Okay. All right, in A, we'll work it down here. The new price is, there's a markup, right? So 1 plus M times original price. The markup rate is 75%, so 0.75 times the original cost is 28. So that's 1.75 times 28, or $49. Okay, so now in part B, they want us to look at the price of these jeans that have been marked up 200% from the sale price now is $42, and they are marked up 200% from the original price, and they want to know the original price. So it's a markup, so I'm going to write 1 plus M times W. The sale price is $42. That's what you're going to pay. We know that the markup is 200%, so if I plug in 200% divided by 100, that would be 2 for M. It's always a little more confusing when the percents are over 100, but yeah, because you're used to seeing a decimal 0.75 here, you know. But if it's over 100%, you're going to get a number bigger than 1 right here. Because if I divide 200 by 100, I end up with 2. Now, the original price is what we're looking for. So 42 equals 3 times W, divide by 3, divide by 3. That's 14. $14 was the original price before the 200% markup. In total, how much have the jeans been marked up in dollars? So that's they want the dollar amount that the markup was. So the price is 42. The original was 14. So the difference between 42 and 14 is 28. Is that right? 42 minus 14. Yeah, 28. All right, number 33. I can do on this page. Let's see. 32 on next page, just to remind you if you're looking at this PDF later. Number 33. All baked goods at Ready Mart are bought from a local baker in town. Miriam buys her weekly supply of cookies from Ready Mart to sell at each high school game. The original price for a dozen cookies is $9.60. Ready Mart increases the price by a markup rate of 25% to make a profit at football games. Miriam increases the price of each dozen by another markup rate of 15%. At what price does Miriam sell a dozen cookies? All right, so it's like 2 markup problems in one, really. So we'll do A right here. She buys it from the Ready Mart, and she has to pay the sales price that Ready Mart charges her. We have to figure out what that is first. So the sales price is Q. The markup is 25%, or 0.25 for M right here. And the original cost is $9.60. So a 25% markup of $9.60 is $12. So she buys them. She pays $12 to Ready Mart. But when she goes to the football game, she has her own 15% markup on that price. So now in the next markup equation, the original price that we need to use is that $12 because there's another 15% markup on top of the first 25% markup. So 1 plus 0.15 times 12 would give us the price that she charges customers at the football game. For $13.80. That's for a dozen. Part B says, how much does Miriam sell one cookie for? Well, that's $13.80 divided by 12 because there's 12 cookies. $1.15, it looks like. All right. I think that's all of them, right? Yep, that's it. I'll put this PDF on Google Classroom as well.